Everyone, and welcome to lesson 22.3. Today's lesson is going to start on page 312 in your Springboard textbook, and you are definitely going to want a pencil handy, either your graphing calculator, smaller calculator, or if you don't have a calculator, please make sure you have up either Google or a great calculator as well is the Desmos calculator, the scientific calculator. You're definitely going to need calculators today. So we've been talking a lot about SOHCAHTOA, right? Sine, cosine, and tangent. And we are now going to be able to use SOHCAHTOA to allow us to find the missing side in a right triangle, even if it's not a 30, 60, 90, 45, 45, 90, or given two sides. All we need is an angle and one of the sides. So what we're going to always start doing is label what we have. So for instance, in our very first example, we are given the hypotenuse and we are given two different angles. So in this case, they're talking about the 41-degree angle, angle P. So we're going to use that as our reference angle. And we're looking for the opposite side of angle P here. So we would use sine because we have opposite and hypotenuse, right? The opposite side is what we're looking for. The hypotenuse is 100. Now, in order to solve for y by itself, we need to get y by itself starting with some multiplication, right? We have this division by 100. We're going to want to solve this by multiplying both sides by 100. And we'll see that y equals 100 times the sine of 41. Now, this is where you need to be very careful with your calculators. We talked a little bit about degrees mode before, but if you have a graphing calculator like so, you're going to want to make sure you go under the mode and you want to make sure degree is highlighted, like mine was not. If you are using an online calculator, like Google, you want to make sure that degree is the one that is highlighted, not radians. You want degree. Or if you're using Desmos, you're going to want to make sure, I believe it comes in degree already, but you want degree, again, being your highlighted mode. And again, we're going to type in 100 times the sine of 41, okay? And what we're going to see is that our answer comes out to be about 65.6 when we do that. So that is going to be the length of our side here for y, right? That's our final answer, 65.6. In the second example, they're using cosine, and they're talking about the 28-degree angle, which is angle O. And this time, we are looking for the hypotenuse, and we have the adjacent side. So that's why we're using cosine, because it goes back to SOHCAHTOA. We have the adjacent, and we're looking for the hypotenuse, so the opposite side isn't involved. That's why it's cosine. So again, adjacent over hypotenuse is how we're going to solve this. Now this time, we have the y on the denominator. So what we can do here is multiply both sides by y. And then what's going to happen is, since it's y times the cosine of 28, it has to equal 18. So we need to get y by itself by dividing by cosine of 28. Again, that's one thing, that cosine of 28. Okay, that's all one expression. So on this one, again, we're going to take 18 and divide it by cosine of 28. Okay. This time, our missing hypotenuse is 20.4. Now, something to notice, a shortcut, if you will, whenever your variable is in the denominator, like it was in cosine of 28 equals 18 over y, a shortcut to solve this is we call it switch and divide, because it quickly puts it in the correct order we need to be able to solve like we did. Okay, so you have a little bit less algebra to solve that. Okay. So that brings us down here to our ways to solve. Okay, so the first way we used was step one, multiply, right? We multiplied when our variable was in the numerator. But on the second example, when our variable was in the denominator, we had to do the switch and divide. Step three for solving is what we're going to talk about in our next lesson. Okay. So if we look at number 2, all right, we're going to start this time. They're not telling us which trig to use. So what we're going to do is we're going to go off of the given angle, which in this case is angle C. And we're going to label our picture with what we have. We have the opposite side. We have the hypotenuse. We don't know anything about the adjacent side, and we're not looking to solve for it. So we're going to leave that to just be blank right now. Now, when we use SOHCAHTOA, right, SOHCAHTOA, based on what we have the opposite and the hypotenuse. Well, we're looking for the opposite when we have the hypotenuse. So the only one that is going to be of use to us right now is the sine, okay? So to set up this equation, we would say the sine of our angle, which in this case is 20 degrees, is going to be the opposite side, which is x, over the hypotenuse, which is 15, okay? And just like we talked about over on the ways to solve, when we have a number in the denominator, in order to get x by itself, we're going to have to multiply by the 15. And we're going to say, okay, 15, if we clear this out, clear all, 15 times the sine of 20 is about 5.13 if we round. Okay? So our final answer for x, 5.13. All right. Next then, another example we see here is in using this triangle here. And again, you always want to start by labeling what you have. In this case, we're given the 10-degree angle, and we want to label our picture based off of our reference angle. So this time we have the adjacent side and the hypotenuse. We don't know anything about the opposite side, and we're not looking to solve for it like we are on the hypotenuse. So if we look at SOHCAHTOA, the best one for us to use here is going to be the one that involves the adjacent side and the hypotenuse, so our cosine. Okay, so for angle F here, we would say the cosine of our angle measure, which is 10 degrees, equals the adjacent side over the hypotenuse, A over H. This is an example, since the variable's in the denominator this time, of when we're going to switch and divide. So now y is by itself, and then 12 divided by the cosine of 10 will give us our final answer. Okay, so back on the calculator here, 12 divided by the, cosine of 10 is about 12.19 would be our length, or 12.2 would be our value for y. Okay. Now, we also are going to be able to use this for some word problems. So we're going to get our drawing skills on. So it says, Trisha is going to make a banner, and she needs to hang up the banner. So she's got a 12-foot ladder leaning against a wall. Okay, and we're going to assume the wall is nice and sturdy. So that's where our right angle is at. And it says the ladder makes a 75-degree angle with the ground. And what we are looking to do is, if we know this is a 12-foot long ladder, we want to know how high up the wall she's going to be able to reach. It says how high up the wall. So there's our ladder, there's our wall. Now, in this case, we are given 75. And if we label our picture, we have opposite is what we're looking for. Hypotenuse is given. We don't know anything about the adjacent side. So the only useful trig to us that doesn't involve that missing adjacent side is going to be a sine. So again, using sine, we can say sine of the angle equals opposite over hypotenuse. Since the variable's on the top, to get rid of the denominator, we're going to multiply If you test this out, 12 times the sine of 75 degrees is 11.6. Now, once we know what this is, how could we find the missing third side? Well, really, you have two options, right? You could either now use, for instance, cosine, because if I want the adjacent and I have the angle measure, adjacent side over the hypotenuse, which we knew was 12, we can solve using trig, or we now have 2 out of the 3 sides. We can actually also use Pythagorean theorem because we have 2 of the sides now, and we could solve for that missing adjacent side using Pythagorean theorem. So what we're going to notice is if we clear this out, whether we use cosine of 75 degrees or we use Pythagorean theorem, what we're going to see is that our answers are going to be the exact same or close to it, about 3.1 and about 3.1. Okay? So either method would give us that same answer. Okay. Finally, try this last one by yourself. What you should have gotten is that this problem is going to require us to use cosine because we have the adjacent side and we're looking for the hypotenuse. And we're looking then to solve this by setting it up cosine of 25 equals adjacent over hypotenuse, switch and divide, and you should have gotten about 17.65 or 17.7. And on the last example here, we are looking at which is going to be correct. Joe says that to find the length of BC, you would use the sine of 40 equals BC over 62. Well, that would be the opposite over the hypotenuse. So sine of 40 equals opposite over hypotenuse. That checks out. But Liam says you could use the cosine of 50 and it would also be BC of 62. Well, if we check out what Liam's argument is, well, we know that if this is 90 and this is 40, to make this equal 180, this angle would have to be 50. And if this was our reference angle, we have the hypotenuse. And if this is the side we're looking for, this is now the adjacent. So we would have to use cosine. So Liam also checks out to be correct on this example. And that goes back to that idea of what we talked about on the last lesson, that the sine of an angle is equal to the cosine of its complement, right? We talked a lot about the sine of x equals the cosine of 90 minus x, the complement. So that's why they both were actually correct in how they could solve for our missing side. We will definitely be working lots more with the solving in class, as well as eventually talking about how to find an angle measure in the next lesson. Thanks, everyone.